I'm Anil Kumar. Welcome to my series on integration. We'll begin with the very first rule on general indefinite integrals. These rules are based on antiderivatives. So I've taken up 4 examples and also provided you with the formula. So integral of a x to the power of n dx is a x to the power of n plus 1 divided by n plus 1 plus c, as it gives a result to a family, right? You can always find the value of c if you know something more about the function, especially the initial conditions or boundary conditions, right? It is important to note that n cannot be equal to minus 1. If I write minus 1, you get 0 in the denominator, that is indeterminate. That means we cannot find integral of 1 over x using this formula. So getting back to derivatives, you know the derivatives of logarithms, right? There you get 1 over x. So antiderivative will involve logarithms. So we'll use that as our rule number 3. Now in formula number 1, you also notice that we could actually place n equals to 0. So that is a special case if n equals to 0. In that case, we are talking about integral of the constant a itself with dx, right? So if you put n equals to 0 here, what do you get? Well, you just get a times x plus the constant c. Is it clear to you? So the same formula can be also applied for integral of any constant, right? So it'll be as shown here. Now using antiderivatives, you know that the derivative of ax plus c is a, right? So that makes sense. Perfect. So these 4 examples have been picked up from previous test papers, and they all are very meaningful. So we have very limited questions to practice. However, each one of them is going to teach you something, right? Now, the very first one, a, is integral of x to the power of minus 1 over 3. Let me rewrite this. It's relatively small. So x to the power of minus 1 over 3. We need to find integral of this particular function. Now, using the rule directly, we could write this as equal to x to the power of minus 1 over 3 plus 1, right? So minus 1 over 3 plus 1. And in denominator also, we get minus 1 over 3 plus 1. And of course, plus the constant c. Now, that gives you 3 minus 1, which is 2 over 3, right? So we get x to the power of 2 over 3, right? Over, definitely this will also be 2 over 3, right? Plus c. So that becomes your result, which you could also write as 3 over 2 x to the power of 2 over 3 plus c, a constant c. It is important to write the constant since you now understand that if you do the derivative of this function, right, with constant c, you get back your function, right? Do you see that? Now that is kind of important to understand. Now a few things to note here are, you see this function, the integral is continuous. However, the integrand here is not continuous at x equals to 0. Perfect. Since 1 over x cube is not continuous, is not defined at x equals to 0, right? So what you learn from here is a very, very important thing, and that is that if integrand is discontinuous at, so this is integrand, right? So what we notice here is, let me write down the note here. If integrand is discontinuous at x equals to, let's say, x1, in that case, then the antiderivative or the integral or we should say integral. So get used to these terms now, right? So integral can be, so if integrand is discontinuous at x equals to 1, which in this case is, at x equals to 0 it is discontinuous, correct? Then anti-integrand or the integral can be, or you say can be continuous. Let me write here. At x equals to x1. Now this is kind of very important to understand. The logic says, well, this particular integral, when you define, you should have written x is not equal to 0, right? Now why have I written this? Because in a multiple choice question at times, the question could be that if the integral is continuous, then the integrand is also continuous. That statement is wrong, and for that statement, this is an excellent example. You get the idea, right? So we'll be learning definitely something more as we are going to solve the questions here. Now you can look into the next question anytime. You can actually pause the video and answer these questions also. Now when we are given in this form, it is a good practice to write them separately, these rational functions, and then we'll get the form for which the formula is given to us, and we can write down our result. So I can rewrite this as integral of x squared over square root of x plus 2x over square root of x minus 1 over square root of x dx, right? And of course all this will be as an integrand. So whatever is inside is called the integrand, right? This word, integrand. Now you can, one more step I will take to write down all as powers of x, right? So we are looking into x to the power of 2 minus half, right? So what is 2 minus half? So you can write here 2 minus half, okay, plus 2x to the power of 1 minus half, right? 1 minus half, since this is in the denominator, minus x to the power of minus half, right? dx. Now apply this formula, right? And don't forget to write c at the end. It makes sense. So 2 minus half, we have to add 1, so we'll take away from 3, right? So for the first one, we get x to the power of, we have here, we'll add 1, right? So we get 3 minus half, right? Correct? So I added 1, correct? And now what I'm doing here is just to save some, we don't have much space here. So 2 times 3 is 6. 6 minus 1 is 5. So I'm writing here 5 over 2. Does make sense to you? Okay. Now this is minus half, right? So 2 times, sorry, plus in between. Okay. So 2 times x to the power of, when you add 1, I mean this is minus half, and when you add 1 you get plus half, right? So 2 minus half you can write, so 1.5. Does make sense, right? So let me rewrite like this. We'll rewrite in the denominator, so we can write this as plus 1, right? So we get 2 minus half. Is it clear to you? Divided by, so we are trying to write this as 1 minus half plus 1, right? So I've written this n plus 1 term here, and I've added 1 here in the exponent, right? Okay, so here if you add 1, minus half plus 1 is what? So we'll write minus half plus 1 here, and you know minus half plus 1 is half, correct? So we write like this, plus c. Anyway, you have to be consistent. I just wanted to share with you different options of writing the numerator, and therefore I followed very different methods for all the three, but all is one and the same thing, correct? Now, so you could write this as 2 over 5 x to the power of 3 minus half is 2.5, correct? So 2.5 is 5 over 2. Is that clear to you? Okay, plus, now this is, when you do 2 minus half is 3 over 2, right? So we get here 2 times, now let me write here x to the power of 4 minus 1 is 3, right? So we get 3 over 2 positive. Now in denominator also we have 3 over 2. Now we'll write this as 2 over 3 in our final result anyway. We'll write this as 2 over 1, right? So 2 times x to the power of 1 minus half is half plus c, correct? So let me squeeze in our final result as 2 over 5 x to the power of 5 over 2 plus, now this 2 goes in the numerator, so we get 4 over 3 x to the power of 3 over 2, correct, minus 2. You could write square root also, x to the power of half. I'll leave it as such for now. Clear? So that is how you have to use this rule and find the integral. It comes straight from antiderivatives. Now here are two examples for you to practice. Now in these examples, you cannot use this particular formula directly. So what you could do here is you could expand and then use the formula, correct? So we'll take the solution of this in the next page. Okay, but we'll continue in the same video. Now here are part C and D. C is integral of x cube minus 1 whole square. Remember the formula, a plus or minus b whole square is what? So that is equal to a square plus minus 2ab plus b square. You could use this formula to expand and then apply the rule. Now here we are using the formula for the cube, right? So if I have a plus minus b whole cube, then it could be written as a cube, right? Now plus and minus. So when it is positive, in that case all are positive. So I should actually write it separately. Okay, anyway, we'll write plus and minus. 3a square b. So plus, so now that may create confusion. Okay, so we'll write for plus first. Okay, so when it is a plus b whole cube, a cube plus 3a square b plus 3ab square plus b cube, right? And if we have a minus b whole cube, in that case we get this alternate minus sign, right? So we get a cube minus 3a square b plus 3ab square minus b cube. So wherever there are odd powers of b, we get negative, since this is associated with b, right? Negative b. So that's the whole idea, to look into the formula. Now once you know all these related formulas, you should be in a position to pause the video and answer. So here is how we are going to solve it. So we are trying to find the integral of x cube minus 1 whole square. Applying this formula, I'm going to expand it. So square of x cube is x to the power of 6, right? So a square minus 2ab, so 2 times x cube minus, right? Plus b square, which is 1. And we need to find the integral of this function, right? So applying the rule, we get x to the power of 6 plus 1, which is 7 over 7, minus 2 times x to the power of 3 plus 1, which is 4 over 4, plus 1 time x, which is x and a constant c. Clear? So we get this as x to the power of 7 over 7 minus half of x to the power of 4 plus x plus c. Is that clear to you? So we have to apply expansion formulas and then we could solve. I'll take up the next rule, which is formula number 2, where you could find direct answer of this using antiderivatives, correct? Now here in this particular case, let's expand it. So we get a cube, which is x cube in this case, right, plus 3a square b, right? So b is 2. So 3 times 2 is 6, right? So we get 6x square plus 3ab square. So 3x and b square is 4. So 3 times 4 is 12. So we'll write 12x plus 2 cube, which is 8, right? So which is 8, and this is what we need to integrate, right? So we get here integral. So straight rule now can be applied to the power of 4 over 4 plus 6 times x cube over 3 plus 12x square over 2 plus 8x plus c. Is that clear to you? Sorry. So we found the integral, right? So now we can write down our answer, which is x to the power of 4 over 4 plus 2x cube plus 6x square plus 8x plus c. So that is how this particular formula can be applied to find the integrals. I hope the concept is absolutely clear. Now you can move down and see the next one, where we'll apply the second formula, which we're talking about the same function directly using the formula rule number 2, we could find the answer. I hope you find it interesting and useful. Anybody who is just beginning with integrals, for them this is an excellent playlist. Take it as a reference material, and I'm sure it is going to help you for understanding all the concepts. Thanks for your time and all the best.